In this video, we will study permutation without replacement and with identical objects of 14 letters taken 12 at a time. This is another way of saying permutation of n objects taken n minus 2 at a time. And this is just the numerical beginning to derive the formula. We have the following question: how many distinct 12-letter words can be formed from 2 A's, 3 B's, 4 C's, and 5 D's in order, and certainly without replacement here? So let's write this word. So here we have the word, and it's clear that we have many identical objects in it. So we have 2 A's, 3 B's, 4 C's, and 5 D's. We notice that the total number of objects in this word is 14, while the total number of objects in the sequence or in the word we are generating is 12. And that means the total number of objects, which is 14, is not equal to the size of the sequence we are generating or the size of the word we are generating, which is 12. So in such case we cannot apply this permutation formula, because this formula stipulates that we are permuting n objects taken n at a time. So we cannot apply this formula. And what we need to find permutation of n objects taken n minus 2 at a time with identical items A, B, C, and D. So what we need to find here numerically is permutation of 14 objects taken at 12 at a time and without replacement with 2, 3, 4, and 5 identical items. Now, to compute the 12-letter word out of the 14-letter word, which is this word here, we can do the following. We can take 1A and 1B from here, and we end up with this word. And we can take letter A and C, and we end up with this word. We can also take the letter A and D, and we end up with 12-letter word. We can also take the letter B and the letter C, and we end up with 12-letter word. We can also take letter B and letter D, and we end up with 12-letter word. And we can take letter C and D, and we end up with 12-letter word. And this is the first set of words we need to use and permute in order to find the number of 12-letter words out of this 14-letter word. Now we isolate these words and we take them to the back a bit and bit up, and we write the corresponding permutation for each word. So here we have a 12-letter word, so 12 factorial, and we have taken 1A off and 1B off, so 2 minus 1 factorial. We have only one identical item, which is identical to itself, and we have here 2 identical items. So we have 2 B's, so 3 minus 1 factorial, which is 2 factorial, and we write each corresponding permutation for each word. We add them together and we get the sum of them. So this is the total number of permutation for these 6 cases. There is also other cases to generate 12-letter words out of the 14-letter words, and that is by taking two A's of, so we take two letters A from here and we end up with 12 letter word. Or what we can do, we can take two B's of and we end up with 12 letter word. Or we can take two C's of and we get a 12 letter word. And finally we can take two D's of and we end up with 12 letter word. And now we isolate these four cases here and we bring them back a bit and we write the corresponding permutation of each case. As we see here, we add them together and we get the total number of permutation for these four cases. So the answer to our question is permutation of 14 objects taken 12 at a time with these identical objects, of course without replacement, is equal to the sum of S1 plus S2, and that is 1,538,460 possible permutation. Question number 2. How many distinct 12-letter words can be formed from 2 A's, 3 B's, 4 C's, and 5 D's without order out of this 14-letter word? So as we have seen before, we have these cases of 12-letter word we can generate, but in this case we don't need to permute because it doesn't matter in which order these letters will be, they are going to be regarded as the same item exactly. So as long as we have here 5 D's and 4 C's and 2 B's and 1 A, it doesn't matter in which order we put them, they are going to be regarded as exactly the same element or exactly the same word. So we have 6 plus 4 and that is equal to 10. And this is combination with identical items without replacement of 14 objects taken 12 at a time. We can also write it in this form here, combination of 14 taken 12 with these identical items 2, 3, 4 and 5 and without replacement equal to 10. Thank you for watching and have a good day.